So welcome back everyone. Today we are going to discuss about a new topic, that is data storage and pointers. So this lecture is exclusively meant for learning pointers, which is a concept in C and C++ only. But we will start it from few terminologies about data storage. We will understand how data is represented in the RAM of the computer, and we will understand the architecture of the RAM. Okay, and then at the end we will study about pointers. So there are many ways or methods of understanding the concept of pointers, but I am going to take the very easiest one, which will make you understand it in a best way. Okay, so let's start with the few terminologies about the data storage. I am pretty sure that most of us are aware of these terms. See here, the first one reads that the smallest unit of storage is bit. Okay, 8 bits make 1 byte. Okay, 1024 bytes make 1 kilobyte. 1024 kilobyte make 1 megabyte, and at same intervals after that comes gigabyte and terabyte and petabyte, zettabyte, like that. That means 1024 megabyte will give 1 gigabyte, and like this 1024 GB or gigabyte will give you 1 terabyte. Alright, so this was about the few terminologies, or you can say units of storage. Okay, we can interconvert storages, right? So if we tell you to interconvert a storage, suppose we know what is the storage limit of the int data type. It is 4 bytes for a 64-bit compiler, right? So we know 8 bits make 1 byte, right? So how many bits in 4 byte? So it will be 4 into 8, that is 32 bits. So what does int consist of? Int has 32 bits. Remember this, we are going to need this in the near future. Okay, so int has 32 bits. Similarly for char, if you consider the example of char, how many bytes char? Char takes 1 byte for all systems, right? So 1 byte consists of 8 bits, so char has 8 bits indirectly, right? So this was few storage related terms or units of storage. Now let's come to the methodologies in which the computer stores the data. Alright, so here it reads that computer can only understand the machine language. We have learned in the lecture 1 itself that computer can understand only one thing, that is machine language, which consists of 0 and 1. Okay, which is the binary notation. That is, when you declare a variable with a data or with a value, it is stored in the memory by after converted in itself to the binary notation. Suppose when you declared int a equal to 4, so how will 4 be represented in the memory? This 4 will get converted to binary, and then be stored in the RAM or the computer memory. Okay, so this was a concept of storage. We already knew these things, right? So now let's see how to convert any decimal number to binary, because see here, this 4 is converted to binary, right? So let's see now, or let's understand now how this 4 is converted to binary. Let's see here, to convert any decimal number to binary, we will now divide the number by 2 and we will note down the remainder. Okay, now we will divide the quotient obtained by 2 again and the remainder again. We will note it, the remainder again. Okay, now how long we will do this? We will repeat the steps until we get a 0 as a quotient, right? Until we get a 0 as a quotient, we will continue dividing the number, that is a quotient. Okay, now we have to arrange the remainders in such an order such that the last remainder which comes is the first one, followed by the rest in the reverse order. Okay, so let's take any random number. For example, here it was 4. Let's convert 4 to binary. Okay, so to convert 4 to binary, we will write 4 first, then we will divide it by 2. So 2 times 2 give you 4 and 0 is the remainder. I am writing the remainder over here. Okay, and 2 times 1 gives you 2 and 0 is the remainder. Right, so what is the binary of 4? So binary of 4 is 100, not 100, 100. I'm very sorry, because it is now converted to binary, so it will be 100 instead of being 100. Let's take any other number, say for example, let's take 10. We will convert 10 to binary. So how to do this? So 2 times 5 give you 10, 0 is the remainder. So 2 times 2 give you 4, but 1 is the remainder. And 2 times 1 give you 2 and 0 is the remainder. So what is the binary of 10 then? Binary of 10 implies 1010. Why? Because it's going from this side and this one also going from this side, because the last remainder has to come first, followed by the rest in the reverse order, right? If you see this line. Okay, so this way we convert a decimal number to binary, and in binary representation only any number is stored in our computer's memory. Okay, let's understand now the architecture of the computer memory, or the RAM, how the RAM is designed. Okay, now inside RAM, here we have separate various blocks, see, and these are the address of the blocks, that is 10, 100, 101, 102, 103, 104, 105, 106 and like up to 115. There are blocks with separate addresses, right? Now what is the unique thing about this block? The unique thing about this block is this block consists of a unique address. See, for address of this first block is 100, second block 103, 2, 1, like this. And also an important feature of every block is that every block consists of 1 byte. Every block consists of 1 byte. That is, the size of this one block 112 is 1 byte. Size of 113 is again 1 byte. Size of 114 1 byte. 115 1 byte again. So what is the unique feature of the block? That it is 1 byte. So let's read what it is said over here. Memory of a computer is made up of various blocks. Okay, which has its own identification mark or address. Identification mark or address, that is 100, 101, 102, right? Next point says that each block consists of only 1 byte. I have mentioned here that each block is made up of 1 byte, right? Now, when we assign a variable in our code, equivalent amount of space get reserved for the variable in our memory. We already knew this thing, that when we assign or declare a variable, equivalent amount of space is getting reserved in our random access memory or RAM. How many space is reserved depends upon the data type of the variable. So how much space will be reserved for a particular variable will depend upon the data type of the variable. Why data type? Because we know that int take 4 bytes. We know that int take 4 bytes. Our double take 8 bytes. Our char take 1 byte, right? These are the basic 3 data types which are important. So like this, if you have a character declaration, it will take 1 byte here, that means 1 block. If you have a integer declaration like this, okay, it will take 4 bytes, that means 4 block. So this 4 blocks, but it will take the 4 blocks in a continuous fashion, that is after 104, 105, 106, 107. After 104, 108 will not come, or 112 will not come. It will be in a continuous manner. Okay. So if this is an int, it will take this one. If we write over here with another ink, this is the memory declaration for int. Okay. This is for a char, that is 1 block. And for double, you can take both the sets over here for 8 bytes. Right. So this was about the understanding of memory. Okay. Let's see. Now suppose we have x equal to 10. Now in case we have x equal to 10. So when you convert this 10 to binary, what do we get? We have already did this before, that x in binary, the 10 in binary will give you 1010, it is already done over here, and we also did previously, so I'm not doing over here. So what is the binary of x? It is equal to 1010. Clear? So when we convert 10 to binary, we get 1010, which has 4 bits. These are the bits 0, 1, 0, 1. Okay. And how many bytes does int take? Int takes 4 bytes. 4 bytes means how many bits? That means 32 bits. We have already done this in the first slide itself, where we learned that 8 bits make 1 byte. So 4 bytes consist of 32 bits. Right? And also 1 byte. Remember that 1 byte is present in every block of the RAM. This block consists of 1 byte. That means how many bits? 8 bit. Right? This block consists of 8 bit. Similarly, this block also consists of 8 bits. And this one also consists of 8 bits. Clear? That means every block in our RAM occupies 8 bits. Alright? Or in other words, you can say every block in our RAM consists of 1 byte. Right? Now since we have 1010, 4 bits over here, what will be the rest bits occupy? The rest of the bits will occupy 0. Okay? So if I write 1010 over here, if I write 1010 over here, which are the 4 bits, and the remaining 4 bits in this block 103 will be 0, 0, 0, 0. That is 8 bits complete. If you count this, this is 8 bits complete. And over here, the rest of the blocks will also be 0. 8 zeros. Okay, one more. And here also it will be 0, 0, 0. 0, 1, 2, 3, 4, 5, 6, 7, and 8. Similarly, here also 1, 2, 3, 4, 5, 6, 7, and over here 8. Right? So this way, declaration of our value is stored into the RAM. So what happens? This 10 is converted to binary, and binary is stored in the blocks. The part which do not consist of any bits get filled with 0. Why I have taken here 4 bytes or 4 blocks? Because every block consists of 1 byte, and we know that integer consists of 4 bytes. So it will take how many blocks? It will take 4 blocks in the memory. So this one, this one, this one, this one. So this thing only in a clear way I did over here. This understanding only, this memory only, it is present over. This is this one. Alright. So this was the data interpretation in the computer memory. Alright. Now let's come to our next concept, that is the final concept of today, that is pointers. So what is pointers? Let's read the definition first and then we will come one by one. See, what are pointers? Pointer is a variable which has the capability or the ability to store the address of other variables. Right? Now, let's take any example, say. Okay, let's take an example. Here it will be C. Let's take an example. Suppose we have this example, char C equal to H. Okay, so how many bytes char has? Char has 1 byte. Okay, let's write over here. So 1 byte of space for char. Right? That means how many block? Only 1 block, which is done over here. So when we declare char C equal to H, this 8 will represent some binary code. Will be converted to some binary code. Okay, and after being converted to binary code, it will get stored in this 1 byte. Suppose 100 block with address 100, it will be storing the char C. So this store char C variable. Okay, so to get this 100 printed on our screen, or to get this address printed on our screen, we take the help of pointers. So if you read the definition now, pointer is a variable which has capability to store address of any other variable. So here, if you see the C over here, what is the address of C? Address of C is 100, right? So address, let's change the ink to green. So address of C is 100. Alright, address of C is 100. So to get this address, we take the help of pointers. Okay, and what is stored in this address? Let's write address clearly now. ADDRES. Okay, so address of C is 100. And what is stored in this address? That is 100 bytes. H is stored. That is this one. And what is the name of the variable for whose address is meant? That is C. Okay. So if you want to write over here, 100 is the, let's change the ink to green again because it's much more brighter and easier for us to read also. So you can write over here, 100 is the address of variable C in the RAM, okay, which stores H character as value. So what is stored in 100? H is stored in 100. Alright, so let's read what is given over here. So a pointer to C will give the address of the C in the memory, and that means we get 100 as an address to C because C is being stored over here. C is being stored over here. Right? C is being stored over here. What is the address of C now? Address of C is 100. How do we get this 100? We get this 100 as a variable which is the pointer. We get this 100 as the variable which is the pointers. Okay. So how do we declare pointers? Let's see. To know the address, how we declare and assign pointers the address of other variables. So we use this asterisk sign, that is star, to declare variables as pointers. So to declare variable as pointers, we use this sign. So how will it look like? It will look like char C equal to 8. This is the normal declaration of variable. Declaration of any random variable, not a pointer variable. Okay, because this is normal thing. We already know this. Random variable. Okay. Now next line C, we write char star ptr, and after that we will assign it over here. Now what is the star ptr? Star ptr over here, ptr is the variable name. Ptr is the variable name. Ptr is the variable name, and this star over here, this star is the what you call declaration of pointer. Declaration of pointer. Right? So what does this statement do? Char star ptr. What is this meaning? Char star ptr is a declaration which declares ptr to be a pointer of character type. Okay. Now what is the data type of pointer? It is an obvious question here. What is the data type of pointer? Data type of pointer. Let's change it to yellow. So what is the data type of a pointer? This is a very obvious question. What is the data type of a pointer? See, pointer has the same data type as the variable whose value it is storing. Now since over here this star ptr, or this ptr, okay. So since this ptr is storing the address of this c, which is the character data type, okay, which is of character data type, so similarly this pointer will be also of character type, okay. Now how to tell the compiler to assign the address of c, that is 100, to this ptr? So how will we tell the compiler? So we will read from here that we assign pointers to store address of other variables, that is c in this case, by using the following, that is the symbol, that is ampersand. This is the ampersand, the same ampersand that we use in scanf. Okay, so when you write ptr equal to ampersand c, what happens is address of c will get stored in the ptr. That is, address of c will get stored into ptr. Okay, so what we do, we will have a variable first normally, okay, and if you want to find out the address of the variable, we will declare a pointer of its type, and after that we will assign the pointer the value of address of the variable by using the ampersand. So this was a theoretical understanding of the pointers concept. Now let's go to VS Code and we will see how pointers are printing the address. Okay, so let's go to the next page. So now let's see about the pointers printing the address. Now see, in the code that we performed, or in the understanding part which we did, we took 100, 101, 102 as the addresses for understanding purpose and keeping it small. I kept the numbers small, but in the real world scenario, the address is a very large number in our RAM. So let's see how we print addresses. So let's declare int a. Int is also a data type and it will also store any address, right? So let's write int a equal to 10. Next, what we will do, we will define a pointer to it. So it will be star ptr, which is the declaration of pointer. You can write over here in comments, declaration of pointers. So let's zoom it for your understanding in a better way. So star ptr, what is ptr? Ptr, the statement does is declaration of pointers. Now we will assign ptr the address of a by the following, by ptr equal to ampersand a. Done. So it is address assignment, you can see. This is IGN MENT. Okay. Now we will print ptr, which is storing the address of a. Printf %d, because address is of numeric type, right? %d, what we will print? We will print ptr. So this is our code, and let's run it. Now see over here, it is coming answer. This is the address of our a, that is 642296, right? This is the address of a. Now over here, if you try to understand a thing, here we can also understand the size of int. We know by default that int is of 4 bytes, right? So what will happen is, it will take 4 bytes. This a will take 4 bytes, and if you declare another int over here like this, int b equal to, we will write int b equal to 50, anything. We will write now int star ptr b, that is pointer to b. Let's make it pointer to a over here. I'm sorry. Let's make it pointer a, ptr a, that is pointer to a, and this is a declaration of pointer to b. After that, let's write ptr b over here, and then we will write ampersand b. Clear? So what will this ptr b do? Ptr b will store the address of b, which is of integer type. So if you want to print b also and a also separately, so let's write here address address of a is this one, and after that, in next printf statement, we will write over here printf address of B is also percentage D, and here comma the pointer to B, that is ptr B. So what this line do? This line will print the address of B. Okay, so let's run this code. We can understand a thing very clearly. So see here. Okay, let's bring it to the next line. It will be easier for us to understand. \n. If you run this code now, see, a very clear thing is demonstrated over here. See, address of A is 64222292, and that of B is 642288. Okay, now if you consider these two things, that 642288 and 622292, the difference between these two is 4. Between 92 and 88, the difference is 4, right? So what can we conclude from here is this B is getting allocated first in the RAM, which is taking 4 bytes of space. Which is taking 4 bytes of space, and after taking 4 bytes of space from 92 itself, from the 92th block in the RAM, our A is being allocated. So what can we conclude from here? We can conclude from here a thing that int is of 4 bytes, right? So like this only we can also find the address on the size of a character also. Let's see how we do this. So for characters of a character, let's change this data type. Everything data type we will change over here. We will take 2 characters. One will be character A and one will be character B. Okay, so let's change this value to single quotes D. Okay, and things will remain the same. Yeah, so let's run this code and we will understand that the size of character is 1 byte. Let's see. So see here now, 642295, 642294. Now the difference between these two addresses, that is this one and this one, is 1. So which proves on the other hand that char is of 1 byte, that is continuously only allocated, and char is of 1 byte. For integer it was coming 4 as difference, which proved that the size of integer is 4, and for character it's coming 1 difference, that means the character is of size 1 byte. So in this way you can prove that character is of 1 byte and integer is of 4 bytes. Okay, so this was about how the pointer is printing the address of any variable. Okay, so let's zoom out and go to our theory part now. So let's understand a very new thing now, which is called the dereferencing of pointers. Okay, this is a new thing which we are going to understand now. Dereferencing of pointers. Now see, we already know one thing, that is pointers is the ability to store address of a variable, right? Now to access the value stored in the variable, its address can be utilized, right? This is called dereferencing. What does this mean? Suppose here I have char C equal to H. Okay, let's define a pointer to C. How we define pointers? It will be char star T. Let T be the pointer, and over here we will add T equal to ampersand C. Okay, now let us assume that this C is occupying this 108 block. In that, this block is occupied by C. Let us assume. Okay. Now, what is stored in this 108 block? The value which is stored here is 8, and the name of the variable which is storing it is C. Okay. Now, once we know this address 108, we can print H directly. And this phenomenon or this practice is called dereferencing of pointers. Now who is giving me this address 108? This P pointer is giving me this address that is 108 in the RAM, right? Now if the dereference 108, if we dereference it, what we will get? We will get 8. This is the output or the value which is stored in that address. Okay. So how we dereference pointers? We use the star operator again to dereference pointers. Okay, that is to print the value at the address the pointer is storing. So here it is another example. Suppose x equal to 8. Let's define a pointer to x, that is star ptr of int type, because this is going to be a pointer to x, this one only. Okay. After that, we are assigning ptr to store the address of x, that is ptr equal to %x, and after that we are printing one line. So what we are printing? We are printing %d, which is the format specified for int, and we are writing it like this. That is star ptr. That means we are dereferencing this ptr. Now if you remember that when we did only ptr, that when the star was not present, we used to get the address of the variable x. But in this case we are using this star operator. That means we are dereferencing the address. So if you dereference any address, you will get the value at that location. So what this ptr is storing? This ptr is storing the address of x. This ptr is storing the address of x, that is this one. And what does the x have? If you dereference this star ptr, what will you get? The value of x. What is the value of x? That is 8. That is this one. So this will give 8 as output. Got the thing clearly? This is called dereferencing. Let's take any other example. Let's take any example, say int a equal to 1000. Let's declare a pointer to it. Int star ptr a is a pointer to a. Over here we write ptr a equal to 10% of a. Now what this line is doing? This lining is assigning the address of a to ptr a. Okay. Now let's write two printf line. Printf %d over here, comma. Then we are writing ptr a. And over here we are writing printf %d, and over here we are writing star ptr a, and then a program ends. Okay, so we are expected to get two outputs, right? Now let us assume that on declaration of this, in the memory 4 blocks are being taken, and let the blocks be 100, that is this one, that is this block, this block, and this block. Let this first 4 blocks are taken for this integer a. Okay. Let these 4 blocks be taken. This 100, 101, 102, 103. Each block consists of 1 byte. Integer has 4 bytes, so 4 blocks will be taken, right? So this is the pointer declaration. Here ptr a is getting the value of a, address of a, I'm sorry. So what this ptr a is getting? ptr a is getting 100. It is 100 ptr a is getting. Okay. So what does the first printf do? First printf is %d ptr a. So what this line will print? This line will print 100 on the output screen. Okay. Let's come to the next printf. Next printf says asterisk star ptr a. So what this star ptr a will do? This star ptr a will dereference, or this star will dereference ptr a. In other terms, you can say this star will dereference this ptr a. Okay. Now what is ptr a having? PTRA is having 100. So star 100 means value at 100. So what is the value of 100? Value at 100 is 1000. That is this one. Understood the thing? This is called dereferencing of pointers. That is to print the address, print the value at an address with the help of pointers. See, we are not writing here printf %d a. That will also give us 1000. Instead, we are using the pointers to print it. Let's see the VS Code. We can understand it in a better way. So let's go to VS Code about the pointer dereferencing. So I will erase everything over here. Give me some time for that. Let's have a pointer. Let it be int or let it be char or anything. Let it be int only. Int a equal to 5. We are more comfortable with numbers. Let be int a equal to 90. After that, what we will do? After that, we will write over here a pointer or define a pointer. Star ptr a. What the star ptr a will do? The star ptr a will define or declare a pointer. Now, after defining a pointer, what will happen is we will give the pointer to the address of a. Okay, so ptr a is getting the address of a by using this line. Okay, then printf %d and we will write is the address of a. Okay, next we will also write as another printf statement. Printf %d is the value of a. Now see, I have not printed any value over here, so let's give the first thing. We want to print the address of a. So to print the address of a, what is the address of a? That is ptr a, pointed to a, and we want to print the value of a. So what is the value of a? Now value of a can be printed in two ways. We can do it by writing a also over here, and we can also dereference the pointer to a, that is by like this ptr a. So %d is the value of a, and how we are writing it? By dereferencing the pointer to a. Now if we copy this line again and we will write this again, and now we will change this ptr a to only a. Both these last printfs will have the same value. Now let's write a new line over here so that we get our output in a much organized way. Let's see what is the output printed. So we are expecting the first one to print the address and the last two to print the same thing, that is 90. Let's see. So this is the address. 642296 is the address of a. Okay, 90 is the value of a, which is printed by this first printf over here. Okay, and after that we are getting 90 is the value of a, which is printed by this printf statement, that is printing directly from the variable, and this one we are printing by using the or dereferencing the pointers, that is by using this star, that is this one. Clear about dereferencing? Only this much about dereferencing. Let's take another example. Let it be to character. Let's change int to character. So let it be char. I'm sorry, char. Char a equal to 90, and we will do nothing here, but we will change the %d in this two things. Why? Because address is a numeric value, so it will stay as %d, and this %c and %c will print characters, so we will change it to the character format specifier. Clear about that one? So let's run the code now, and let's give a character value in single quotes. Let it be x or caps lock c, anything. So let's run this code now. So when you run this code, see here 6422299 is the address of a. Okay, c is the value of a. C is the value of a. Capital C is the value of a. So First is the dereference of pointer, and second one is the printing the variable itself, value of variable itself, which we are already familiar of. So what this line is doing? This line is dereferencing the pointer. Clear? So that was all about dereference of the pointer. So we will see our next thing what we have for today. So the next thing we are going to see now. What is the next thing we have? So the next thing which we have is pointer to pointer. Okay. Now see, we use pointer to store address of variable. Right. Let's see this. We use pointers to store address of variables. Right. Now pointer is also a variable, right? A pointer is also a variable. Why? Because in the definition of pointer, if you remember over here, I wrote that pointer is a variable. Right? So, since pointer is a variable, once it is declared, it is also supposed to store some memory. Right? Now, as pointer is a variable too, we can store the address of this pointer to other pointer, because pointer is also taking some space in the memory. This pointer variable is also taking some space in the memory. Right? So, for that, we declare pointer to pointer. Okay? So, how do we declare pointer to pointer? Suppose, let's consider this example which is done over here. So int x equal to 10. Okay. Then we are having star ptr. What the star ptr is doing? Star ptr is storing the address of x. The star ptr is storing address of x. This is pointer to x. Okay. This is the assignment of address using ampersand to ptr. Now, we want to store the address of this ptr. So, how will we store it? We will store it with the concept of pointer to pointer. So, what we will now define is, we will define another pointer by using two asterisks. Why? Since this is the ptr2 and this is going to find out or to store the address of a pointer, so we use two asterisks, that is two stars. So to store the address of pointers, we take two stars and we will write the variable name, which will be a pointer to pointer. So what is this pointer ptr2 pointing or storing the address? This ptr2 is storing the address of this ptr. This ptr2 is storing the address of ptr, not the address of x. ptr2 is storing, to write over here, ptr2 is storing address of ptr, not address of x. Right? And what is ptr2 over here? ptr2, you can call it as pointer to pointer. ptr2 is a pointer because it is storing the address of a pointer. Right? So in this way, we learn about pointer to pointer. Now, let's consider the following code. See here, this is dereferencing of pointer to pointer. So what this code is doing, let's understand. X equal to 10. So when you write x equal to 10, suppose after reading this x equal to 10, okay, let's understand the code, then we will run it manually. So first we have x equal to 10, then we have a pointer declaration, very good, of integer data type. Then what is this pointer storing? This pointer is storing the address of x, very good. Then we are having a double pointer, which is ptr2. What this ptr2 is storing? ptr2 is a pointer which is storing the address of ptr, like the previous one only. Okay. Now, see a thing. Printf %d star ptr2 star ptr2. This will give us 10. It is written. Now let's see how it is giving us 10. when the compiler reads the first line, int x equal to 10 in the memory. Okay, suppose this is our memory. I'm drawing it big for a reason only. Suppose this is our memory, and in our memory a space will be created for x. Suppose this one is created for x. This block consists of 4 bytes and this is the x. And what is the value it is storing? That is 10. So it will have 10. And let its address be 100. Okay. Let its address be 100. Very good. Well enough. Now what we have is int PTRs. In start PTR. Okay. So PTR is of int type. So it will take another block. Okay. Very good. This is a PTR. What is this? This is a pointer. This is supposed to store any address. So whose address it is storing? That is %x. So x address it will store as a value. So what is x address? X address will come over here in this block. That is 100. Now this pointer also has an address. Let it be 200. Okay. Let it be 200. This pointer will also have an address in the memory. Because it is of int type, it will take a space. Right. Now see the next line. That is int star PTR2. This is a pointer to pointer. So once you write star PTR2, another block will be created over here for PTR2. Because PTR2 will also take some space because it is a pointer. Star PTR2. Very good. Now what this star PTR2 will hold? This pointer to pointer will store the address of PTR. What is the address of PTR? That is 200. So 200 will be stored here as value. Clear? Now let's dereference it. That is, let us go backward. So this is star PTR2. Star PTR2. Let's bracket it one by one. PTR2, then over here 1, and the entire thing. Let's bracket and let's resolve this bracket. What is PTR2? What is PTR2 having? PTR2 is having this 200. So let's write it in this way. That is star, and here we will write star 200. Very good. Okay. What is now this star 200? What is the star 200? That is dereferencing of this 200 address. I'm sorry. That is dereferencing of this 200 address. So what we will get? We will get 100 over here. So let's write now. It will be star 100 now, because star 200 is giving us this 100, which is the value of PTR. Okay. Very good. Now we have a last thing, that is star 100. Very good. What the star 100 will give? Star 100 will give, or asterisk 100 will dereference the 100 address. That means it will print the value which is stored in the 100 address. What is the value in 100's address? If this is 100 and this is the value, so it will give us 10 as output. Understood the thing? What we do? So we dereferenced a variable using a pointer to pointer, right? So we are accessing the value of variables by using pointer also. That was a simple term. And here what we have seen, that we are addressing or accessing the value of any variable by using a pointer to pointer also. That is by dereferencing pointer to pointer. Alright. So this was dereferencing double pointers. Okay, so let's see in our VS Code how we dereference double pointers. Okay, let's go to VS Code. We are in our VS Code now. So what we do is over here, let us remove everything, or let's keep this line and comment out everything. Let's keep one line for the time being and comment out the rest lines. We have A equal to C, start PTR is storing a declaration and PTR is storing the address of A. Very good. We will declare now another pointer which is also of char type. This char star PTR2, which is a pointer to pointer, so it will have double stars. Star PTR2 is a pointer to a pointer, so it will have 2 stars. Very good. Now we will assign PTR2 to store the address of PTR by like this. PTRA. Very good. What is PTR2 now having? PTR2 is now having the address of PTRA. Very good. So let's make the changes in the printf statement. We are done with our code now. So %d address of A. So let's change this A to PTRA. So first what we will do is we will print the address of PTRA. Who is storing the address of PTRA? PTR2 is storing the address of PTRA. Okay, very good. Next line, what we will do, we will printf the value of A is, it is of character type. We will give %c, then comma, dereference 2 times, and then we will write over here PTR2. Very good. So what we are supposed to get? We are supposed to get C as output, right? We are supposed to get C as output. So let's run this code and let's see if we are getting our required output or not. So first what we will get? First we will get the address of C. Oh, I'm sorry, the address of this pointer, not the address of C. We are going to get the address of this pointer. Okay, let's see. So see here, 642292 is the address of pointer A. Okay, not the address of A. 642292 is the address of pointer A, PTRA, and the value of A is C, which is our output. That is how we are getting? We are getting by dereferencing pointer to pointer. That is by using this line. Alright. So this was about dereferencing of pointer to pointers. We will implement this in our code. In our practice part, we will implement this. Right? Let's go back to theory now. So we learned about dereferencing pointer to pointer. Now there comes an obvious question. What is the size of pointer? If we consider pointer storing some data in the memory, so how much byte allocation that a pointer takes? So see, pointer size is dependent on the type of compilers. For some compilers, for example, the online compilers that we have, that is online GDB and program widths, okay, there we have 8 bits. The pointers take 8 bits. But if we take MinGW compilers, it is taking 4 bits. I don't know what is the reason behind this. So pointer size is dependent upon the compilers. For some compilers it is 4, for others it is 8. But it is fixed for a particular type of compilers, irrespective of the data type. Irrespective of the data type, that is whether it is char, whether it is int, whether it is float, it will always take the same amount of memory allocation in the memory, irrespective of the data type of the variable whose address it is stored. So for your case, the size of pointer may be 4, and for my case it may be 8, but for my case it is 4. For your it may be 8. Okay, so this was about pointer, size of pointer. Okay, let's see the next thing what we have. Now we have a very important thing, that is pointer to an array. Okay, so what is an array? Array is a collection of similar types of data, right? Collection of similar types of data. Okay, so what does the array name do? So what it says here is an array name is a constant pointer. Array name is itself a pointer to the first element of the array. Therefore, this declaration in the declaration below. If we consider this int a equal to 5, so if we declare like this, if we write like this, int star ptr, this is the pointer declaration, and next line we will write ptr equal to a. So if you write ptr equal to a, what will ptr have? Ptr will have the address of what? Ptr will have the address of a of 0 always, because the address name, that is the array name, always points to the first element of the array. Okay, and for that we do not also need the ampersand over here. Okay, so when you want to store the address of any array, we do not use ampersand, because the a itself is a constant pointer which points, that is the array name is a constant pointers which always points to the first element of the array, that is array of 0, right? Okay, so if you read the thing, a by default refers to the address of the first element of the array, that is a of 0. Okay, so pointer to an array will refer to first element of the array, and hence we don't have to assign pointers, ampersand to assign pointers to store address of any array. So for this reason we do not use ampersand. Why? Because the array itself, or the array name itself, always refers to a of 0, that is the first index of the array. Okay, next comes an important thing, that is pointer arithmetic. Now if you have seen the addresses printing part, we have seen that all the address are numeric value. Now since it is a numeric value, therefore we can perform arithmetic operations with it, that is we can increment it, decrement it, add it, subtract it. But pointer arithmetic is different. Why different? Because once you do like this, int equal to, let a be an array 0, and okay, let's do this in the compiler itself, because we will understand it in a better way. Let's go to the compiler and we will understand this pointer arithmetic and pointer to an array together. So let's go to the pointer and let's go to VS Code now. So we are in our VS Code, we will learn pointer arithmetic and array of pointers, pointer to an array, I'm sorry. So let's erase everything over here. Okay, so let's do over here int a, let's have an array of 5 members, and let's assign the value 1 2 3 4 5. Very good. Now what we will do, we will print the array using pointers. Very good, we will print the array using pointers. So how will I do this? I equal to 0, I less than 5, I plus plus. So let's see how we print this array normally first, that is by using %d, then a of I. So what this code will do, this code will print the address of, I'm sorry, this code will print the value 1 2 3 4 5 1 by 1. Let's run this, we are getting or not. So see, 1 2 3 4 5 is getting printed. Okay, very good. So how did we print this? So we printed this using the a of I, that is we are using the array name itself along with the index to print the members of the array. Now what we will do this, we will define a pointer to an array. So let it be star ptr, a pointer name. Now let's assign pointer name the address of array, that is ptr equal to a. See here we are not using the ampersand over here. We will not use ampersand because a itself refers to the a0th location, that is it will print 1. Okay, very good. Now what we will do here is, we will write over here ptr and we will dereference ptr. So if this loop was not present, or if it loop was present also, what we will get every time? What we will come? We will get 1 5 times, right? Because this star ptr is printing 1, because this ptr is always getting the address of a0th location, right? So if you run this code, we will get 1 5 times. See, 1 1 1 1 1 is coming 5 times, because this A is always referring to the A 0th location. That was about the array part. Now we will implement pointer arithmetic over here and we will print the entire array. So if A is getting, if PTR is getting A 0th location first, now its next location will get the number 2, right? Because array is a continuous memory and memory storing always happens in a continuous way. I have mentioned that. If int A is 4 bytes, that means 101, 102, 103, 104 is being occupied. It is not 101, 108, 112, right? So array storing is a continuous type. So if we increment the address now, that is PTR, now we will increment it by 1. What we are supposed to get? If we increment PTR by 1, we are supposed to get this 2, 3, 4, 5, like that. So if you run this code now, we will get 1, 2, 3, 4, 5. This is why, which will print the entire array. Right? We are getting 1, 2, 3, 4, 5 by dereferencing the pointer to an array. Right? Now see, we are not printing the array by you controlling the index. How we are printing the array? We are printing the array by dereferencing the pointers to an array. So first, the output is coming PTR. That was 1. After that, we increment PTR to go to the next address. That is, if the first address was 100, we are incrementing PTR plus plus. So it will go to 104, not to 101, because integer take 4 bytes, right? So if you increment PTR plus plus, it will be 104. And what is present at 104? 2 is present at 104. So 2 will be printed. Then again 2 will be printed. Then again there is PTR plus plus. So it will go to 108. What is there in 108? 3 is there in 108. So 3 will be printed. After that 108 will increment by 4 again. It will be 112. 4 is present at 112. 4 will be printed. And after that 116. And what is present at 116? 5 is present. So 5 will be printed. So this way we can print the array by using pointer to an array and also by pointer arithmetic. Right? So this was all about the concept of pointers which we have. Let's see what we have next. So next we will have few problem solving where we will solve few problems on pointers. Okay. See, I have 3 questions only which will be easy for us to understand. So declare integer, character, floating point pointers, and this pointer will point to a different variable. Through this variable you need to read data and display the data using pointers. We already did this. Let's do this again. So let's remove this. So we will have int a equal to 90, char c equal to over here d, anything you can keep. Then we will have float d equal to any number 123.3 or 12.3. After that we will assign pointers to it. Int star ptr a, then int star ptr c, then over here star ptr f, I'm sorry, d. Very good. Let's assign the pointers their value. So here let's assign the value. We'll write over here ptr a is storing ampersand a. Next we will have ptr c, that is pointed to c, is storing the address of c. Very good. Now ptr of f will store ptr d, I'm sorry, will store pointer to d equal to ampersand d. Very good. Now I did a mistake over here. This data types of pointer will change to char and float because it is storing the address of a character and a floating point, and that is for int, that is remain intact. So what we did, we declared pointers. Okay, we cannot assign value, sorry, we have to accept the value from the user. Okay, so what we do here is we defined the variables, and when we assigned pointers to the variables to store their address. Now what we will do, we will accept the value from using scanf. Scanf %d, over here we will write ampersand, and then we will write star ptra. Very good. Then we will write scanf %d star ptr, then ampersand star ptr b, c. Okay, then it will be scanf, and over here it will be %f. Let's change it to %c first, because it is printing a character, accepting a character, and comma. Here it will be ampersand star ptrd. Very good. Things are done, but over here we will apply a getChar. So what this getChar will do, now see here, since we are accepting a character after input of integer, when we press enter after giving an integer, enter is also considered as a character. So that character will be stored in %c. It is the scanf. So to avoid that, we write getChar, which is the function which will accept a character and will do nothing. Okay, so it will accept the enter, and then we have to enter the value of character. Okay, so let's write a printf statement here for our better understanding. Printf, what we are accepting, integer, then char, then float. Okay, very good. Now we will print all the statements, okay, using the pointers. Let's copy these lines. Okay, Control C, Control V. What we will do, we will print, change this scanf to printf. We'll write printf. I'm sorry. So like this, print, print, and in this ones we will write f, and here also f. Okay, and we don't need a getChar now because we are printing. Very good. Enter, and here let's delete this line, and then apply new line in every case. So here, and here we will write \n. So let's run this code and see what we are getting. So first one will print the integer, then the character, then the float. Okay, so let's see what we are getting. Let's run this code. So in here we have to remove the ampersand. I forgot to say you. We have to remove this ampersand. Very good. Let's run this code and let's see we are getting our expected output or not. So it is asking for us the value of integer. So let's give a value of any integer. Suppose say 56. Then getChar is getting this enter. Then we have to enter the char value. This, let it be capital T. Very good. Then it is asking for a floating point value, that is a decimal value. Let it be 57.904, or let it be 57.94. anything you can get. Now after pressing enter, we are getting 56T and 56 point this recurring value. Okay, it is getting rounded up. Okay, so this way we are doing the pointer thing. That is, we are accepting input by using pointer also, and we are printing the values using the dereferencing of pointers. So here we are not using ampersand A, ampersand C, ampersand D. Other than that, we are accepting the value using pointers. We are accepting the character value as pointers, accepting the floating point value also as pointers. Okay, and we are printing it also by dereferencing the same pointers. Okay, very good. So this was our program number 1 being solved. So if you want to take a screenshot, let me zoom out so that you can take a screenshot. So this is the code. If you want to take a screenshot, you can obviously take from here, right? So let's move to our next question. This was all about the first question. So this is our second question. Let's see what does the second question says to us. So it is saying that take 2, it will be 2 over here. Take 2 variable which are pointed by two pointer variables, you need to interchange the data of the pointers using pointers and print the output. That is, in other words, we have to swap SWAP. We have to swap the things. Swap the values of two variables using pointers. Very good. Very easy. Let's do it now. So what we'll do, we will erase everything over here except these things, and also let's remove everything. Very good. So here we have int a equal to 5, let it be 10, and let it be int b equal to 90. So after swapping, a will become 90 and b will become 10. So let's do one thing. So here we have declared a pointer to a, and now what we'll do, int star ptr b. This is a pointer to b, and in pointer to b, what we will have the address of b. Now what we are up to do, we are going to take a third variable, int temp. Okay, what this temp will do, let's assign temp 0. It is a good practice. So what will this temp will do? Temp will store the value of ptra, value of a, that is by dereferencing the address, that is ptra. Temp is storing the address. Now what will star ptra have? That is, what will the value of a become now? It will become the value of b, that is star ptrb. Okay, and what will star ptrb? Star ptrb will be temp. Right? So we are done, and what we will do, we will print. So the value of a is value of a after swap is percentage %d. Here it will be ptra, and in the same printf, let's do and value of b after swap is, and here also percentage %d, comma star ptrb. Very good. So here we have to write swap, not here. Here we have to write swap swap. So we are done, and let's make the thing much more beautiful to understand, so that we can clearly see how swap is being implemented. So here we will change after to before. before. So one is before swap, we are printing the values. Okay, and then after swap, we are printing the values. So let's see how this is being implemented. So see, here we are getting an error. What is the error? It is saying in function main ptra is undeclared. Why ptra is undeclared? Let's check. Okay, so we are getting the error for this one because ptra is declared after this lines. So this was the case, and here we will print what we will do here, we will do nothing. We will keep the line as it is, and we will print the values of a and b before the swapping operation, that is before here. So now it will work because ptra and ptrb is declared after this. Okay, so let's run this code now. So here we see value of a before swap is 10, value of b before swap is 90, and then we are getting, and let's apply a %n over here so that we get every output in a new line. Okay, so let's do this now, and here we will remove spaces, so we'll get our output in a very beautiful way. See here, so value of a before swap is 10, value of b before swap is 90, and value of a after swap is 90, value of b after swap is 10. So if you see the value of a and b are getting interchanged, which is the purpose of our program, right? So this was about the swapping concept using the concept of pointers. So this was all about question number 2. If you want to take a screenshot, let's zoom it. So you can take a screenshot like this. So this was all about the code where we are swapping it. So where does the swapping operation takes place? So after the declaration of temp, This is the swapping algorithm. Just this one. SWAP. Right? So in this position, the swapping is being implemented. That was all about the code. Okay. Let's see the next question what we have now. We have the last question now, that is take three integers, each are pointed by 3 or more pointer variables. It will be 3 only. You need to find a minimum using the pointers. Very good question. Let's open VS Code, implement this. So we are having two integers already declared, and let's take another integer, that is int c equal to 89. Okay, what we'll do, we'll declare a star ptr c. What will star ptr c have? What will ptr c have? The address of c. Very good. Now instead of swapping here, what we will do, we will print, we will comment out this one. We will print here, that is we will find the minimum. Okay, so we'll now apply if else. Okay, so we'll find minimum now. So how we do minimum? So if star ptr a is less than star ptr b, okay, and then inside this is called nested if, and if here and here, let's apply now. If star ptr a is less than star ptr c, then we will print printf. That is star ptr c, that is this will print the value of the minimum number, is the minimum. Okay, then what will print? That is star ptr a. This will print a if a is minimum. So let's copy this one. Okay, let's paste it 2 times. So we will change the credentials now. If star ptr b is less than star ptr a, and here also star ptr b is less than star ptr c, then we will print star ptr c b is minimum. Same for here also. If star ptr c is less than star ptr b, and over here, and if star ptr c is less than star ptr a, then we will print star ptr c is minimum. Very good. Let's comment or delete this line. We don't need this now. So this was about the code. Let's zoom out a bit. This was all about our code. So let's run this code and let's see if our program is working properly or not. Okay, so what we will get as output, we are supposed to get 10 as output. Let's see. So here we are getting 10 is the minimum, because 10 is the minimum among this. Now let's change the value to 10 to 100, and what we will get this time, 89 is the minimum. So let's see, 89 is the minimum. So let's change 89 to 890, and we want to get 90 as minimum. So let's clear out the screen and let's run this code, and we are getting 90 is the minimum. So in this way we are comparing 3 numbers and printing the numbers using pointers. See here, we are not comparing the variables directly, that is ABC. What we are doing, we are comparing their pointers. Okay, so this was all about the question. If you want to take a screenshot, you can take. I am zooming out. So this was all about the code. Okay, so in this way we implement pointers in our program. So that was not all about pointers. Okay, so this was not all about the pointers. We will have, or we will implement more pointers after we study string. There we will implement pointers more. So this was all about pointers. The concept will remain the same, and we will implement it much more in the string part. Okay, so remember that pointer is an important or exclusive feature of C and C++ only. There is no pointers in Java also, because in Java the memory is allocated on its own and it is managed by the compiler itself. Okay, and we cannot see it. It is most important. So this is the flexibility of the C, where we can see where our number is stored in the RAM. We can print its address. Okay, so this is the ability of a pointer. Okay, so this was all about pointers. See you in the next video. Thanks for watching.